going to find the derivative of a function using the chain rule with the fundamental theorem of calculus, of integral calculus. The fundamental theorem of calculus is that for every function there is a antiderivative that would be the integral. So first, let's say we have a function f of x is equal to the integral of the defined integral from a to, I would say, some function of x, g of x, of another function, w of x dx. So let's say that h of x is the integral, defined integral from a to x of w of x dx. And well, here is g of x. So f of x is equal to h of g of x. That means that whenever we see a x here, we are going to substitute it for g of x. Alright, so now what is the derivative of f of x? So f prime of x will be, this is the chain rule, will be h prime of g of x times g prime of x. So here it is the derivative of h of x. This is h of x. What's the derivative of a integral? Whatever it be, it would be the function w of x evaluated as this, at x. So it would be w of x. But now we are seeing what h prime of g of x. So it would be w, so f prime of x would be h prime of g of x. This is just h prime. This is h prime of x. H prime of g of x would be w of g of x times g prime of x. Let's say, for example, we have f of x is equal to the integral from a, could be just a number, could be 1, 2, whatever, to sine of x of 2x minus 1 dx. So h of x is the integral from a to x of 2x minus 1 dx. And g of x is sine of x. Now, f of x, is equal to h of g of x. So the derivative of f prime, so the derivative of f of x, that is f prime, will be h prime of g of x times g prime of x. So what is h prime of g of x? We said that the derivative of the integral of whatever we're taking is whatever we're taking, that is just 2x minus 1. So h prime of x is 2x minus 1, evaluating at x, so it's just 2x minus 1. Now h prime of g of x is substituting x with g of x. What's g of x? Sine x. So it's 2 sine of x minus 1. And g prime of x is cosine x. So f prime of x is equal to 2 sine x minus 1 times cosine of x. So this is the kind of the chain rule. Now let's verify this with this example. Let's say here we have this. So let me actually compute this in order to see that this is the result. So we have the integral of this is x squared plus, minus x, and this is evaluated from a to sin x. We don't need to worry about the constant because when it is a defined integral, they will just cancel. So this is f of x is sine square of x minus sine x plus a square minus a. Now, what is the derivative of f of x? You know, these are just constants, so they will cancel. This would be 2 sine x times derivative of sine x, that is cosine x, minus derivative of sine x is cosine x. Here, if you expand this, you have 2 sine x cosine x minus cosine x. So you can be pretty sure that the chain rule works, this kind of chain rule, and it doesn't matter what value we have here, because even only if this is just a number, it doesn't matter what it is, because here when we take the derivative, these that are just constant will go will be 0, so they will not count.